Imagine yourself being paralyzed. You cannot move anymore, you cannot talk anymore. We developed a new technology here that actually allows you to communicate again simply by using your brain directly.
We are able to look into how brain signals can be used for patients that cannot communicate with their friends and family anymore after suffering from a stroke. I foresee that such a system can actually be brought into rehabilitation centers such that they can use the system in order to train as many patients as possible that can benefit from it.
The research that we do here is essentially around developing these systems that allow people to communicate by using brain activity. And what is needed there is first of all the neuroscience. So how actually are these intentions to speak encoded in the brain activity that we can measure with EEG electrodes.
We record these brain signals typically with EEG caps. Did you know it is possible to decode those brain signals, to make sense out of these very noisy recordings that we get from such devices by using computers that can actually learn from data in order to get an idea what kind of brain activity, what's going on in a user when we record these signals. We are able to look into how brain signals can be used for patients that, for example, have a cognitive impairment. This language training has been developed in collaboration with clinicians from the University Medical Center in Freiburg, my colleague Christina Musso. A patient that comes to us to train with us would need to sit in this ring of loudspeakers. We are playing a lot of words from those loudspeakers while the patient needs to pay attention to only one of them. We see difference in brain activity if a patient manages to listen to the target word and ignore the other words, compared to playing any of the non-important words. We also work on different applications of these machine learning methods. One of the examples is shown by my colleague Jordi Thielen.
What we are currently working on is develop the methods that can generate the brain activity that is most useful, such that from the brain activity we can pick up whether you're looking at the A or the B. Pierre is using his brain to select a symbol. That symbol is flashing with a particular pattern. That pattern creates specific brain activity that is different from all the other symbols, simply because these are flashing with different patterns themselves. Therefore, from the brain activity, we can actually see which pattern Pierre is looking at. We can select which symbol Pierre wants to select. Participants are really important for us, simply because, of course, we need to test these algorithms. You can see your live brain activity on the screen, and you can actually communicate via your brain activity. So this is actually quite a wow factor. Finally, of course, you're contributing to the science is actually developing these assistive devices for people that are actually in need, that actually have no voice anymore. We can now give a voice to communicate again.